Hello, this is Jason Harrington, and today what we're doing is section 7.3, which is dealing with approximations of integration. Okay. What we're going to do is we're going to learn how to approximate. Instead of using rectangles, we're going to use a different shape. So here's what we're going to do. Let's consider a trapezoid, which is a better shape than just a simple rectangle that we've had before. So a trapezoid, as you know, is going to have a base, two parallel sides, but the two sides are not the same height, and they're connected like so. So these are 90 degrees. Okay. Now, this side I'm going to label as y sub 2, and I'm going to label this side as y sub 1, and I'll label this side as x. Okay, so we know that the area of a trapezoid is just simply going to be A is equal to, it's just going to be the average of the two different sides times the base. So it's going to be y sub 1 plus y sub 2 divided by 2. So it's just the average of those two times x. So it's kind of like a square, length times width, or a rectangle, length times width. It's just that this one is going to be the average. Okay. Now, here's what we're going to do. We are going to partition. So now we're going to do is consider y is equal to f of x, some curve, okay, on a to b. And we're going to partition a to b with n subintervals of equal length. Of equal width. And we're going to use trapezoids instead. Now this is a very visual section, so make sure that you actually can see the trapezoids in there. And we're going to use the trapezoids to basically approximate the definite integral, or the area. The area under the curve y is equal to f of x from a to b. Okay, so again, this is a very, very visual section. So here's what I'm going to do. I'm going to draw out from x to y. This is the x-axis, and that's the y-axis there. And I'm going to go from A, 2, 3, 4, 5, dot, 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 to B. Okay? So I'm going to have some curve here. And what I'm going to do is I'm going to, at each piece, I'm going to basically draw a line and a dot at each piece, like so. Now where the trapezoids come in is that you're going to connect the lines there. Now you can see that this is going to be a much better approximation than just a rectangle. Okay. Dot, 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 and then we're going to have some last trapezoid there at the very end. Okay. Now what's cool about this is that the delta x doesn't change. So in this case, our delta x is still going to be the same. It's going to be b minus a divided by n, the number of subintervals we have. So just b minus a. Okay, the first little guy is going to be x1. And then we're going to move over delta x. And then we're going to get x2 as our second point. We're going to move over again delta x, and then we got x3. Move over delta x, and then we got x4. Move over delta x, and then we have x5, dot dot dot. Alright, so let's actually figure out what the formula is going to be. And then, of course, the last one, the b, that's going to be our last guy. So that's going to be xn. Now the formula for this is actually pretty easy. Okay, so here's what we got. The trapezoid, the nth trapezoid, so the n is the number of subpartitions that we have, is going to be equal to, and again I'm using this formula here, it's going to be the average heights times the width, which is just delta x each time. So it's going to be f of x1 plus f of x2 divided by 2. And then the width is going to be delta x. So this, right now, this first piece is just the first trapezoid. And that's all that is. Plus, now I'm going to do the same thing again for the second down. Now this time I'm going to have x2 to x3. So that's going to be f of x2 plus f of x3. Take the average, so that's divided by 2. And the height is delta x. That's the average of this, the two heights there, times delta x. Plus, and I'll do one more, f of x3 plus f of x4 divided by 2 times delta x. Okay, and that's going to be this particular trapezoid right there. And I keep doing this for a while. So then I'm going to go plus dot 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 plus, and the last one is going to be f of x n minus 1, the one right before this guy, plus f of xn divided by 2 times delta x. And that's pretty much the formula, but we can clean it up a little bit. Now what you'll notice is that each term has a 2 and a delta x, a 2 and a delta x, a 2 and a delta x. So it's delta x divided by 2 is in each term. And so we can just easily factor all those little guys out. Okay, so that's going to be equal to delta x divided by 2. And let's see what we have left over. We're going to have f of x1 plus f of x2 plus f of x2 plus f of x3. So just to be clear, this is coming from the first little guy here, just this piece, and these two guys are coming from this piece, plus dot dot dot, and I'll put the last little guy here. That's just going to be f of xn minus 1 plus f of xn. Now you can see some things here. Again, this is the last guy. Now lastly, the thing that you should really note here is that there's a couple of repeats. F of x2 is in here twice. F of x3 is in there twice. F of x4 will be in there twice. In fact, they're all in there twice except for the first guy, which is only in there once, and the last guy, which is only in there once. But everything else is in there twice. So again, these two guys are in there twice, and those are in there twice, so forth and so on. So what we have is that this is the formula. We have T sub n is going to be equal to delta x over 2, and you have the first guy. You only have one of those, so the first one is the only one that you have one of. That's the first starting guy. And everything else you have twice. So it's 2 times f of x2 plus 2 times f of x3 plus 2 times f of x4 plus ... plus just 1 of f of x to the last one, f of xn. So what you'll notice is that literally everything else is in the middle. So what you do is you partition it up. You're going to have delta x divided by 2 in brackets, and you're going to have the first guy plus 2 times f of x of the second guy plus 2 times f of x of the third guy, however many pieces that you have. And then the very last one is, of course, by itself. So the formula, this is the formula you should know. And what I'll do next is just a couple of examples.